All right, we are going to pick up where we left off with our Codecrafters Redis challenge in Zig. So today we're going to write a parser. So if you missed the first video, I will put that right here, I guess, and we'll pick up with the parser today. So I've got the Codecrafters dashboard up for build your own Redis using Zig. Today we need to implement the echo command. This command itself is not actually too complicated. What we're going to do, though, is we're going to take the time and actually implement a parser, mostly a full parser at this point. It might be slightly incomplete, but it should be most of the way there. And the goal here is to essentially lay the foundation that we can build upon for the rest of the challenge as we push through this. Okay, so taking a look at this, you'll add support for the echo command. There's links to the Redis docs. I'm going to pull those up because we're probably going to refer to those. Echo is a command like ping that it's used for testing and debugging. So it accepts a single argument and returns it back as a resp bulk string. So the thing that I really want to look at is resp, R-E-S-P, which is the Redis something protocol, I would assume. And the key thing here is that we want to make sure that we have a way to read and write resp, since that's what we need to do. The tester will expect to receive something like this as a response. That's the string hey encoded as a resp bulk string. So let's actually pull that up. And that, that's what we would get when we say echo hey. Suggest that we implement a proper Redis protocol parser. Yep, we will start with that today. Command names are case insensitive, so echo, echo, and echo are all valid commands. So we'll just do something where we do like a case insensitive compare. The tester will send random strings as an argument to the echo command, so you can't hard code back a response. Okay, that's fine. We're at the point where we're actually building something, so hard coding is probably not very useful. The exact bytes of your program will receive won't just be echo hey, they'll be something like this. Okay. You can read more about how commands are handled here in the Redis protocol. So we can view code examples, screencasts, and test cases. Not particularly interested in all of these at the moment. I will say that I did a little bit of research. I looked at a couple Go implementations of a parser, and then even a couple Zig implementations to get a rough idea of kind of how I want to approach this. So I've got our existing implementation up on the screen, and I do think someone commented and left some feedback that I was not deinitializing something. So okay, this thread pool right here needs to be deinitialized. So what we can do is a defer standard thread pool deinit, and then we can pass in our pool here. So we'll make sure that we clean up after ourselves. Great thing to do. We're going to make some changes to our main function to better support this. So I found a couple more things that we can use to clean up the handler. And we're also just going to make some changes. So essentially what I want to do is a multi-step approach. So we've got our main method, we have a handler, and then our handler is going to fire off essentially processing a request. And the reason I want to do that is because we can do all of our error handling in the handler, and our process request can just kind of aggressively try everything that it's going to do and handle the errors at the handler level. Maybe it's not the best approach, but I think it will work pretty well for our use case. So, okay, let's go ahead and define our process request function. And what we want to take in is essentially, we're going to take in a reader and writer from the connection, but we also are probably going to need an allocator. So I'm going to go ahead and take in an allocator, which is going to be a standard.mem.allocator. We will take in that reader, which is going to be a standard.io.anyReader. And we'll take in that writer, which is going to be a standard.io.anyWriter. I mentioned this before, but we don't really need to return anything except errors. So we will do an error void return type. And then what we'll do down here is essentially read the request, check if it's a certain type, dispatch on that type. And you'll kind of see how that comes together here in a minute. So we have our handler. We're going to go ahead and modify this handle function to support this process request. So the very first thing we're going to do, we have a GPA up here on line 7. We're going to go ahead and make this thread safe. Like so, I believe. Come on, Zig language server. Good enough for me. It looks correct. We'll find out in a minute if it's not. And then once we've done that, we have a couple different things we can do. So in the case of our handler, I think what we want to do is add our allocator right here. So we'll pass in our allocator to pool.spawn. And then in our handle function, we need to accept that allocator. So that'll be a standard.mem.allocator, like so. Zig is not wanting to let my stuff save. Oh, so slow. Allocator connection, still uncertain about that. Okay, I went ahead and restarted VS Code because it seemed to be having some issues. I've had a couple people ask about the LSP and VS Code, for the LSP and Zig, I guess. I've mentioned this in comments, but I figured I'd mention it here too. I generally code in Vim. I've had some feedback that said that Vim is hard to follow for YouTube videos. I don't necessarily agree with that, but the feedback keeps popping up, so I've decided to use VS Code for more YouTube-focused items. So with that in mind, hopefully the language server will actually, okay, yeah, it seems to be working a little better. And if not, I'm not sure if it's the language server or the Zig extension that I'm using or what exactly, but I may end up going back to Vim just to make sure that we can actually get through this. So we are closing the stream after we write to it. I think we probably just want to pull that up here instead so we can defer connection stream close. This reader that we're getting, we can actually pull that down here. We'll group the reader and the writer together. I kind of like having my defers at the entrance of the function, not somewhere farther down. Hopefully most people can see why. It just makes it a little easier to follow what is being cleaned up when the function closes, and this ensures that it does actually execute. Okay, so we have a reader, we have a writer that we want. So this is going to be connection stream writer. And this gives us a reader and a writer, but we want to convert these to an any reader and an any writer. So we can use the any method. And this is essentially kind of what you would consider to be like an interface. Let's see if we have a good example. So we have a generic writer that we have access to with write all, print, some methods like that. There's this any that returns an any writer. And you can see here that it has a context, which is doing a pointer cast to self context, and then a typed erase write function here that is being passed in. So we actually might end up doing something like this for commands. It seems like that could be a really nice way to approach commands, but we also may not. So yeah, we'll find out. We'll see what we come up with. Okay, so we have our reader, we have our writer. I'm going to create an arena here. I feel like this is a really good case for an arena. So we'll do a standard heap arena allocator init, and we need to pass in the allocator that's going to be used by the arena, which is the one that is passed into this method. So now that we have that arena, we also want to defer, sorry, not yet. We need to get a handle on the arena allocator. So do something like arena alloc is equal to arena.allocator, and then we can defer arena alloc.dinit. Is that not correct? It's arena. It's just the arena, isn't it? It's not the arena allocator that we need to deinitialize. Okay, cool. Well, if that's the case, we probably should keep this side by side right here. So we have our arena allocator, we have our reader, we have our writer. Let's change this. We actually don't need this buffer. And what we can do instead here is do a while true process request. We want to pass in our allocator. Specifically, we want the arena allocator that we've created. So if you're unfamiliar with arena allocators, There's a ton of good documentation online about them, but the idea here is that they can group allocations together, and instead of us having to free each item individually, we can just deinitialize the entire arena and deallocate that memory that is being consumed by everything in the arena allocator. Okay, let's also pass in our reader and our writer, and we want to catch. And if we catch an error, I don't know, handle error. For now, let's just return. Semicolon there, and then we can remove this Pong piece because that'll only be relevant for certain pieces. So let's write what this could look like so we can handle that Pong. So we essentially have a request that's coming in, and this is going to be a resp request. So if we look at resp over here, we can find resp versions. So you can see there's information about resp, simple strings, REST protocol description, the request response model. Requests can be pipelined, which is interesting. Pipelining is enabling clients to send multiple commands at once and wait for replies later. Information about the network layer, simple strings. So we're going to basically build out some of this. Maybe not all of it. I don't think we need to get into certain pieces, but most of them we can get into. Okay, so we're essentially going to get in a request. So we'll take in a request, and then we will check to see if it is a type. So if request.is, and then maybe we say something like ping, then we want to do the Pong command. So it would be a ping is equal to something like commands.ping. And then we can do something like return ping.execute. So these don't exist yet, and we'll have to make them exist. And I guess for execute, we'll need a writer, so we'll pass in a writer as well. So this is kind of the flow that I'm thinking. And hey, it's me again. Quick break, really quick. My dogs are definitely in a mood today, and they are all over the place making noise. My apologies. I really want to finish this video, so I'm just going to push through it, and, sorry if it's not of the quality that you'd expect, but yeah, let's get back to it. Okay, so we have essentially we have this mocked out or stubbed out. We actually need to go in and create these now. So what I'm going to do is I'm going to create a new file here, and we'll start with the commands because that one should be easier. So we'll do commands.zig. And essentially for what we have here, we're going to do two different commands. We have ping, which we have to support. And I think the other one was echo, right? Add support for the echo command. Yep. Okay, so what we can do here is we can go ahead and import the standard library. So import standard. And then actually, I think that might be all that we need for right now. So we can go ahead and define a struct for ping. So we have a struct here. We're going to do a public function called execute. And this is kind of using the command pattern, but if we were to abstract this via an interface, which I do like the idea of doing, maybe we'll try to do that at the end and see how it shapes up. We would use this execute function as the core part of that interface. So we're going to get a pointer to a ping. I don't think we need our ping struct since we're not actually doing anything with it. And then we'll have a writer here, a standard io.any writer is what we're passing in. And this can return an error or void. All we need to do is try writer.write all. And ping's a really interesting one. We can save on processing by just hard coding the value because it's always supposed to return Pong. So in our case, I think that should be everything we need for the ping struct. We know we need to support an echo struct too, so let's go ahead and define what that could look like. So this would be something like echo is equal to struct. We're going to have some values that get echoed. So we have some values. These are probably going to be a slice since it could be multiple items. Not really sure on the type. So maybe we come back to that. And then we would have a pub function execute execute. There we go. Self, a pointer to the echo command, and then a writer of a standard.io.any writer. Return type error void. And then essentially we just want to do something like check to make sure it's a valid command. So in our case, we could check self.values.length if it is I guess if it's not equal to 1, because can we echo multiple? Is there an example of echoing multiple? Echo message. So it's a single string. So it won't be, okay, that makes sense. So it's a single string. So it actually will only be a single value. So we could essentially check that, yeah, if this is not equal to 1, then we can return error invalid command. And let me come back to this error here because I think that's important. But otherwise, we can just try self values. Actually, it's really just a value, isn't it? So it would just be a value. We still need to give that a type. I'm just going to call it a value for now. Self.value write, and give it a writer and let the value choose how to write itself. Okay, 2 things there. So the first one, the error one, that one's really straightforward. If you haven't used errors much in Zig, custom errors, this is essentially setting up errors on the any error type. It's kind of wild. You can just type whatever you want after error dot, and it will create an error type for you and make that available. So I could be like, well, that's a bad example, but that could be, to my knowledge, a valid error. So we don't have to define these somewhere else. We can just return them in line and work with them as if they were available on the any error type, because they are. So the second thing, so the RESP protocol that we have here has different values, and these different values are both written to our server and written from our server in a standard format. So to approach this, what we need to do is essentially make sure that each value can write itself in the format that it needs. So assuming we have a value here, we can do self.value.write. That does assume that this value implements write, but we'll need to do that. So we will have to implement that as we get going. Okay, so assuming that we have those values, we're going to have an import in this file. This doesn't exist yet, but this will be something like resp.zig. And it'll be maybe a resp.value, since resp is the whatever it would be called here, the protocol, Redis serialization protocol. Okay, RESP. RESPECT. Cool. Feel pretty good about this. Let's get into the meat and potatoes of this then, which will be the resp file. So we have resp.zig, and boy, is this going to be a big one. Okay, so we're going to go ahead and import the standard library. I am sure we need it at some point, so let's go ahead and import that. We have a requirement that we need to support echo, echo, and echo, all in different sensitivities, or cases, I should say. So we essentially need a case-insensitive match on strings. There's actually a really clever way to do this without any additional allocations, which is kind of neat. So I think I'm going to take that approach, and insensitive equal. And what we're going to get is essentially a const of U8s and another set of const U8s. And we just want to return a Boolean, because if they're the same, it's true. And if not, then it's false. We can do an early exit here. So if the length of the two is not the same, then they're obviously not the same. Otherwise, we can do a for, and we want A character, B character, and we're just going to compare the characters one at a time. So instead of us like taking a value that's a string and then trying to manipulate that string or to lowercase it or something like that. We can just iterate through each character individually. And I think this should help us avoid an allocation. I might be over-engineering this. There might be a cleaner way to do that without an allocation. But what is coming to mind for me would be this approach. So, and truth be told, this idea I did end up seeing in another Redis implementation. And I thought this was a clever way to approach that. So I figured this might be a good way to tackle it. So we can to lower that single character. So we have AC, and then we want to check and see if standard ASCII to lower is equal to the B character. And if they're not equal, then we want to return false. Otherwise, we can just keep going. And if we keep going and we get through both the strings, then we know that they are in fact the same, so we can return true. So that gives us a case instance of equal without any allocations, which is nice. That's less allocations to worry about. And then, so from the RESP perspective, RESP, we have values that we need to work with. So we have a pub const value is equal to struct. And then we also have a request. Pub const request is equal to struct. So we need to implement those. Value is without a doubt probably going to be the most complicated of the two. So maybe we start with the request and then work our way back to value. So we know that a request is essentially going to be a, well, it'll be a command and then a collection of values. So we can go ahead and define these properties on our struct. It might be easier to just start with value. No, let's go from the top down. So we'll start with the request, then we'll get into values later. So we still don't know what value is, but we can keep a raw value on hand. We can also keep track of the command. So that'll be a string. And then we can also keep track of like args, which will be a slice of values. So you'll essentially have something like, these are actually not great examples because they're not very complex. But for example, you could have, well, ping wouldn't have any args, but echo would have a single arg, which would be the string that it's supposed to echo back. We also need an allocator, so let's go ahead and define an allocator on our request. This will be a standard mem allocator. We'll probably use the arena here. In fact, I'm positive we'll use the arena here. I don't know why we wouldn't. Arena allocators are really nice with request response cycles because I can allocate everything on a request and then free up the arena at the end and clean up everything associated with that request, which is really nice. And seeing that we have the word request with a capital R probably makes sense to use that arena allocator. We do need to allow us to deinitialize our request. This will return a void. And then we really just want to free up that value. So this is going to be a slice of values. So I don't think we have anything to worry about there. Yeah, so the only thing we need to free up is the value. So it'd be self dot raw value dot, I don't know, dinit. We'll stick with the same pattern. And then we'll need to give it an allocator. And again, I guess if we're using an arena, if we know for a fact we're using an arena, I guess we don't technically need to worry too much about this. But our code here isn't aware that it's using an arena, and it seems maybe not like the best practice to just assume that you're going to get an arena and have access to it. So let's work with any allocator as well. That being said, we will almost certainly use the arena. I don't know why we wouldn't. Okay, so we essentially need to read a request and write a request. And now that I think about it, I think we're going to have to go implement the value before we can actually start to reason with how this is going to work. So we have an allocator for read. We have a standard IO any reader. Why did I type reading? I meant reader. And then this is going to return like an error request. So this will sort of be kind of like a constructor, I guess, in our case. We need to read the raw value. We need to check if the request is valid. Yeah, okay, we'll have to come back to this. We'll do the same thing with write. We'll go ahead and just stub it out. So pub function write, and then what we want is self a request, and we want that writer, which is going to be a standard.io.any-writer with a error void return type. I think we're going to have to figure out what the value write looks like before we can actually implement that. So what else do we have? We'll probably, so if we go back to our main method, we have a like is that we defined here. So if it is ping, for example, so we can do a pub function is, this will be a self request, and then we have a command that we want to check against. So this will be a const u8 slice. It's going to return a Boolean, if I can type correctly. I think we can actually handle this one already. So this will be return case insensitive equals self.command command. And this is how we will check if it's a ping or an echo or whatever it is. Okay, so we have a pub. What else do we need? Hell, that might be it for now. That might be it for now. Okay, let's figure out what this value looks like. This thing is going to be the meatiest part of this, so probably good for us to go ahead and figure it out. So a value is essentially going to be one of many types, which already makes me think that a struct is maybe not the right approach for this. So we actually probably want to use a unioned enum. So if we do union enum, and then we can define what those look like. Zig union enum. Let's pull that up. So the Zig guide, so you can see here, unions allow you to define types that store one value of many possible type fields. Only one may be active at a time. That's exactly what we want. We're going to have something that's either an integer or a string, but it can't be an integer and a string, so that's perfect. There's unions here. You can see examples of how you would use, you can see examples of how you would use tagged unions, which are unions that use an enum to detect which field is active. That's what we're going to do. And then the shorthand that we're doing is basically this right here. So we have this approach with union enum, and then we're going to specify our fields. So our first field, we're just going to name these after the types that are available here. So we have simple strings. So we have a simple string, which is going to be a const u8. We have simple errors. So we have an error, which is going to be also a const u8, I think. What else? Integers. So an integer is going to be an I64. Let me make sure that's correct. I'm pretty sure that is. Yeah, okay, 64-bit integer. So it'll be an I64. So that gives us strings, errors, ints, bulk strings. Single binary string. Redis limits it to 512. $sign at the first bytes. Okay, so we have essentially another type of string. I'm just going to call this string since we called the first one simple. This will be a const u8 as well. Arrays. Okay, so these have an asterisk as the first byte. Okay, cool. So array. So this is going to be a slice of values. It'll reference itself, I think. I don't see a way around that, and I think that's probably the most correct option. What else do we have? Nulls. The null data type represents non-existent values. Nulls encoding is the underscore character followed by the CRLF terminator. Here's nulls. Okay. Due to historical reasons, RESP2 features specially crafted values for representing null values of bulk strings and arrays. always been a redundancy, 0 semantical value to the protocol itself. RESP3 aims to fix this wrong with the null type. Okay, cool. So we have essentially a null. It's a reserved word. Let's go with null string. And we don't need a type for that since it is essentially undefined. So we have simple, error, integer, string, array. I think we're good, at least for now. We can come back and implement some of these more complex types later. Okay. We know that we need to deinitialize it, a deinitializer, because we are calling that deinitializer down here. So let's go ahead and define that. So we have a pub function deinit. It'll take in a self value allocator. It'll be a standard mem.allocator, and it needs to return void. So if our value is something that is going to take up space, we need to free it. If it's not taking up space, we don't have to worry about freeing it. So the things that would not take up space in our case would be the integer and the null string. I'm going to move those closer together because they're going to behave fairly similar in a lot of cases. So let's go with that. So what we can do is essentially with the tagged unions, especially with enums, what we can do is switch on our self. And then we can say, hey, if this is a simple or a string or an error, then we want the value. So we're going to capture that. And this will be the value of that string or simple, I guess. The name on this is kind of hung up on the names, but it shouldn't matter too much. So we can free that value. Not a semicolon, we want a comma because we want to handle the array case. This is actually going to be pretty similar. Oops, we do want that. We need to capture that value. So we have the array, and then we can just do 4 items in array, capture the value and do v.deinit, and then pass in the same allocator. So if we have an array of values, we're just going to, and deinitialize each value individually. Yeah, and then we can call allocator.free on the array itself to free up that memory. And I think that's it. I think the other types, null string and integer, we don't need to support. So we could do an else here and just nothing. But I think one thing I do like about using these unions is using these union enums, the tagged unions with an enum, is avoiding this else. And the reason why probably won't be relevant in this video, but maybe the next one. So if this is a null string or an integer, don't do anything. And the reason why I'm doing that instead of the else, though, is because if I do an else and I add more types to this, it won't tell me that I need to worry about implementing how to handle deinitializing for that type. But if I were to add a new type and then try to compile, I have to support that type somehow because I am switching on self and we're not handling that. It's not exhaustive. So I think that now I'm starting to doubt myself. If I'm not returning anything here, that might not be the case. Either way, I feel like this is more clear than saying everything else does nothing. Okay. Rambling a bit. Sorry, this is starting to drag on a little bit. So we probably need access to an is for a value just to see if that value is the thing that we say it is, which will also use the case insensitive string. Sure, let's go ahead and implement it. So we have function is and then self value string, and this will be a const u8. This is going to return a bool, and it's basically going to be what we have below. Actually, no, it'll be slightly different, won't it? So we can return, and this should be exhaustive. In fact, we may end up using an else for this. No, let's not. So let's switch on self. If it's a simple or a string, then we want to capture the string and do a case insensitive equal on S. Well, why did it struct me? S and string. If it's not one of those, so if it's an array or an error or a null string or an integer, false. We can just assume that these can't be equal. For the sake of our check here, this is check. These can't be equal. Does that make sense? I ask that a lot as if I'm live streaming or talking to a colleague. I know you can't respond, but I'm just going to assume it makes sense. Let me know in the comments below if it doesn't make sense. I'll try to clean that up. Okay, so now we need to worry about reading and writing. This will be the hard part. So we essentially have a lot ahead of us. So let's start with writing. Yeah, let's start with writing. So we'll create a pub function write. It's going to take in a self value. It's going to take in a writer. This is going to be a standard.io.any writer. It's going to return an error void. And we essentially want to do a very, very big switch. So we're going to switch on our self here again. You'll see this pattern is quite common, at least in this implementation. And if it's a simple, we're going to capture that string. And then we're just going to do try writer print. We have a comp time format that we have to handle, and then we need to pass in S. Yeah, this format. So simple strings. Let's go take a look at them. Okay, it's pretty straightforward. It's encoded as a plus character followed by the string. Mustn't contain a carriage return or line feed and is terminated by a carriage return line feed. For now, we're just going to assume that you're not returning a carriage return or line feed in the simple string. So I think this should be good for the simple string. Let's do the same thing with strings. They're going to be a little bit more complicated. But the short and sweet is that we will also just do a try writer print. And that's a typo that I don't want to make, so let's fix that really quick. So strings are different. So we can see that bulk strings, it's going to be a $, followed by the length, followed by carriage return line feed, followed by the data, followed by carriage return line feed. Okay. So we'll do essentially the same thing, but it's going to be a $, and then it'll be a digit, and then the string, and then carriage return, and then line feed. So we need to return, or we need to pass in some more args. So we'll do s.length, and then s. I think that should be pretty good. We need to handle arrays. So array is going to be a. Let's take a look at arrays. Okay, so we want to write the number of elements, carriage return, line feed. Okay, actually is not as bad as I was expecting. So we'll do a try writer print $, asterisk, digit, and then carriage return, line feed. And we need to give this some args. So we'll do, well, it's really just the size, right? So it'd be array.length. One of the nice things about working with a writer like this is we can just continue to print to the writer through multiple print calls or write calls or whatever we want to do. So because we're implementing this write method, we can actually sort of not necessarily recursively handle it, but we can call the write method on the value itself. So we know an array is essentially a slice of values. So we can just say, hey, write yourself, and it should take care of writing itself. So that's what we'll do. So for each item in the array, we have a value, and we want to say try v.write, and then we're just going to pass in that writer and let the value write itself. So we have our array. We're going to do a null string. Null strings are nice and easy. So we do a try writer. They are easy, right? Let's double check. Yeah, okay, nice and easy. So let's do a writer.write all. I'm very curious about the resp2 nulls. I mean, it's been fixed with resp3, but I'm also very curious what those look like. I don't see a link to resp2 or any information on it, so we'll just continue with what we have, but I am very curious. So we have a null string. I think that should be it for the null string. We have an error type that we need to handle. So for the error type, we can create another method to handle writing an error. Actually, I don't know if we really need to, do we? Okay, so let's just try writer print. Okay, so resp has specific data types for errors. Simple errors are similar to strings, but their first character is the minus. The difference is that the client should treat errors as exceptions, where the string is the error type of the basic message itself. Okay, that's not as bad as I was thinking. So in this case, we essentially just have the same thing that we would have for a string, except it is minus r/n, come back over here, and then we need to pass in the error, I guess. Oh, we need to capture the error. So let's capture the error, slice. I think that's correct, so that should be good. And then the last one we have to support is integers. So let's capture our integer into an I. And then this one should be really straightforward as well. So this should just be try writer.print. And we need to give this a format. So we'll do colon. It is colon, right? Integers. Come on. I'm pretty sure I saw that. Integer. Yep. Okay, cool. And then we have essentially a plus or minus. Okay, I think that's how to read this. Oh, optional plus or minus sign. Okay, yeah, that is how to read it. So, okay, yeah, those are really straightforward. So we'll just do the digit, and then we'll do a carriage return line feed. And then we have the value that we want to pass in. And I think we should be good with that. So I think that's our write method. Let's take a look at our read. And before we get into reading, I just want to call out why this write method approach is helpful. And it really boils down to this array. So we know that if it's an array, it's an array of values, a slice of values in our case. Or I guess this is an array actually. But the point being that a value knows how to write itself. So since we have this write function that says, hey, this is how a value writes itself, we can just iterate over the values in the array and have them write themselves. So they'll call this a bunch of times. For each item in the array, it'll call it once. But it takes care of all the formatting and writing for us, which is great. Okay, so we'll do a similar thing with reading, kind of, but it'll be quite a bit different. We actually won't have a value because reading is essentially going to create a value for us. We'll take in an allocator because, Lord have mercy, I bet we're going to need to allocate here. In fact, I can't think of a way where we wouldn't have to allocate here, so we definitely will go ahead and take that in. and an any reader, and this will return an error value. Okay, feel pretty good about that. So we're essentially swapping off of this first byte. So if it's an error, it's a minus. If it's a plus, it's a simple string. If it's a colon, it's an integer. If it's a $, it's a complex string or a bulk string. Arrays are this asterisk. So let's switch off of that then. So let's get the first byte. So this will be first byte, and this will be equal to try reader dot read byte. Give me that byte. And then we're going to switch on the first byte. And since this is a character and not a string, we can switch on this, which is really nice. So we'll do a $, because a $, is our bulk string. And if it is a bulk string, we want to handle that. What other types we got? We have the minus for an error. We have the plus. We have the asterisk. 1, 2, 3, 4. I think that might be it. Anything else will be return error unsupported value. Something like that. So we're switching on these types. Let's do some stuff. I think the simplest will probably, we'll come back to bulk strings. They're going to be arguably the most complicated. Those or the arrays, I guess. Okay, so let's handle the minus case. So this is essentially just the error case, which is really straightforward. All we're going to do is return. We're going to do an anonymous struct because we know the type is a value. So we're going to try to read line. We're going to give this an allocator. And we're going to give this a reader. Read line doesn't exist yet. We're going to have to make that. We essentially want to read in the whole line and get the value for it. We don't have that yet. So let's go ahead and build a read line method. So we'll just put this underneath. Let me add that comma before I forget. So we'll do pub function. Actually, this doesn't need to be public. So let's just do function read line. It's going to take in an allocator. It's going to be a standard mem allocator. We have a reader here, which is going to be a standard IO any reader. And then we're going to have a slice of U8. Okay. We need to essentially allocate space to store the line. So we're going to create a list of U8. So this will be a character list. Don't know why I typed of. Standard array list U8. And then we need to initialize that with an allocator. Okay, now that we have that, we can defer list dinit because we are going to be able to clean that up here in our line, our read line function. We can set up a variable for the previous byte. So let's do previous is equal to 0. I'm going to give this a type because if I don't, it's going to be a comp time int, and we don't want it to be a comp time int. We want it to be a U8. So if you run into that being a comp time int, I don't think you can set the value of that variable because it's comp time. So if we tell it it's a U8 instead, we should be able to set it. So we can say while true, we just want to keep iterating over these bytes. So let's do a const byte is equal to, sorry, I'm going to specify that this is also a U8 just to be safe. Try, and then we want to do like reader.read byte. Give me those bytes. If the byte is equal to, sorry, this is a character, so a new line byte, then we can break. Otherwise, we want to keep going. So let's try to append. Yeah, append. Never can remember the method name on lists, array lists. So we'll append that byte, and then we want to set the previous equal to byte. And the reason we're keeping track of the previous is that when we're finished, if the previous is a carriage return, we want to remove the carriage return. Is that necessary? Okay. I think that's an over. I think that using previous here is probably an over-engineered optimization, a premature optimization, over-engineering. Let's just remove it. There's no need. So if we hit \n, we're good to go. We've hit the end of the line. Finish. What we can do here now is return list.toOwned slice. So whoever gets this is going to own the slice, and they're going to have to free it. But I think that's okay. Okay, so we have our read line. Feel pretty good about that. We know that this is owning the slice. We are storing in the error. We also have our deinitialize method to clean that up, so feel pretty good there. So let's do the same thing here for the plus, right? So for the plus, we want to do a simple string. So this will be .simple, and this will be try, read, line, and then something like allocator, and then reader. Should still be the same between those two types. Okay, so the complex ones. So we have our arrays, and then we have our bulk strings. So I actually think the arrays are going to be a little easier, so let's start with those. So let's do a const. We essentially want to get the length of the reader. So we probably need to write a method for that too. So we have const length is equal to something like try read length of the reader, catch maybe. No, we're trying it, so we should be good there. So we don't need to catch it. So let's just try to read the length of the reader. We'll need to implement that. Let's just go ahead and do it. So let's create another function called read length. Having a hard time speaking at this point. And that read length is going to take in a reader, which is going to be a standard io.anyReader. And this is essentially going to give us a usize. Work through this read length method. I'm not 100% sure what this is going to look like, so I might just do this in silence and then come back over it in just a minute. So let's do that. There is so much reading involved in this. Okay, so we have our read length function. Read over this, copy it down if you need to, follow along. This video is already going on really, really long, and we still have quite a ways to go. So I'm going to skip over the explanation for this. I'm also going to go ahead and implement a read seek function, seq, S-E-Q. I'm not really sure how to shorten that, but we essentially need to read a sequence of values. So we're going to go ahead and implement that as well. Okay, one of the key things about this read sequence method, read sec method, is that the sequence that we pass in is comp time, which allows us to do inlining and kind of work with these strings with a little bit more depth than we would get at runtime. So it's just the reason we pulled this out to its own method is for comp time and inlining. Okay, with those implemented, again, feel free to pause the video and copy these down if you need. Sorry that we're not going to go through them. I'm just trying to get us through this tonight. It's already much later than I realized. But okay, so we have our read method, right? And we want to try to do some things. So we're going to try to read length. What else? We can get that length, and then we need to create an array, which is going to be a standard array list We have comp time here. The comp time is going to be a value. And then we need to init this with an allocator. And then we can defer. We essentially want to clean these up. So your standard defer for an array list. So for each item in the array, v.deinitialize with an allocator. And then finally, we will do array.deinitialize as well. Just your standard cleanup, nothing going on too crazy there. We want to make sure that the array is big enough to hold all the items that we need to hold. So we can try array.ensure, I don't know what the difference is, hold exactly new capacity or at least new capacity. Let's just do ensure total capacity. We don't need the precision. I'm not really sure when you would want that. I guess if you're working with really fine memory constraints, you might want to use that. But in our case, we have a little bit of freedom here. So let's use ensure total capacity. And now we can iterate. So we can do from 0 to the length of items in the array. Let's see. Const value is equal to something like try read. Pass in the allocator, pass in the reader. Okay, this is feeling good. Feeling good. Try array.append value. And then at the end of our for loop, we can return an anonymous struct with an array, something like try array to owned slice, something like that. We do need to probably clean up after ourselves if something were to go wrong. So we can use error defer. This is a defer that only happens when an error is triggered. So we can deinitialize, whoops, one too many. We can go ahead and deinitialize that value if we run into an error trying to append it to the array. What is this expected loop payload? Oh, we need to capture, I don't really care about the value, so we need to capture nothing in our case, but we do need to capture something to actually make this valid syntax. Okay, feeling pretty good, feeling pretty good. I think the thing we're missing up here is the bulk string, so let's go ahead and knock that out as well. I think we have everything we need. It'll actually be quite similar, might be slightly easier than the array, but essentially what we want to do is try read length reader const data is equal to try allocator.alloc. We're going to store, my goodness, what am I doing wrong? Const data, try allocator, try allocator.alloc. Okay, there we go. We want to allocate U8, how many bytes we want to allocate the entirety of length for data. We can do an error defer here, allocator.free to free that up should anything go wrong, because we're going to do several things right now that can go wrong. We'll try to read no EOF, read that into data. That's our buffer. And then we can try to read the sequence, which is reader, and then that sequence is going to be carriage return line feed. And then finally what we can do is return string is equal to data. Okay, so I think that's our read method in a nutshell. So we have that. Feel pretty good about value, pretty good about writing, pretty good about reading. Some helpers to make reading a little easier. We need to go flesh out our request now, because now that we have read and write done, we can actually use those for the request. So for reading, we can do something like const raw is equal to try value.read. We can use that method that we just created. We'll give it an allocator. We'll give it a reader. We can do an error defer here. Do raw.dinit allocator. If raw is not equal to an array, or raw.array.length is 0 if it's empty in our case, or raw.array is not a string because that would be a nonsense command, we can return error invalid request. So just circling through this. So we know that the raw value is going to be an array. It has to be an array or else it's not valid. If there's no items to it, it's invalid. You just sent me a blank string or a blank command. If the first item in the array is not a string, that's invalid too. Because if we look at all these commands that they support, they're all going to be strings. So we're handling the invalid case. What else? Actually, I think if we handle that invalid case, what we can do is return our struct and do allocator is equal to allocator. Oh, need a dot right here. Dot raw is equal to raw. Dot command is equal to raw dot array index 0 dot string. Missing a comma up here. I'm going to go ahead and get that added. And then args is equal to raw dot array. And we'll take a slice of the raw args for the args of the request. Okay, that's read, I think. I think that's read. Probably should write some tests, but thankfully Codecrafters gives us tests. So we'll just run it through Codecrafters and see how it works. Let's do another try. We'll do value.write. So we're always, interesting. So we're always going to write an array out in a request because it's by nature, it's going to be an array. So we need to write, okay. Let's go back to our value. I thought we were done. It turns out we're not. We have one more thing that we should do. So I'm going to create another method up here and I'm just going to call it pub function, and it's going to be called, let's go with write array header. So it'll be write array header. And what this is essentially going to do is just write the first piece of an array for us. And the reason we're pulling this out is because we're already doing it below. So it'll be any writer, it'll take in a size, which is a use size, and then it will be a void return type. So we're doing that, right? So when we have an array, this is the header that we're essentially writing. So we can just take this, paste it right here. I guess it becomes slightly more complicated. So we have our asterisk, we have our $sign. No, it really doesn't become more complicated. We just pass in our size right here. And then what we can do is essentially say try write array header. We're going to pass in our writer. And then for our size, we want to pass in array.length. Okay, feel pretty good about that. The reason we do that is now we can come back here and we can actually try value.write array header, writer, and then we know that given the response that we're writing, we're going to have the length of args plus 1. Should give us enough space. Yeah, okay. So plus 1, and then we will write the value itself. So this is going to be, we're going to write a specific value because the responses we return are going to be strings. So we have a string, which is going to be self.command. So it'll be the command. And actually, in hindsight, I don't know if we need to implement a write method, but we're going to stick with it because the write method it would be mostly used by clients, but we'll go ahead and flesh it out anyways. Yeah, writing values would still be something we need, but maybe not necessarily the request. Either way, we're going to go ahead and finish it. We've started it. Why not? So we have our command that we're writing, and then we need to pass in a writer. So we're going to pass in our writer. And then finally, we need to write each arg. So we can do self.args, we can capture the arg, and then just do try arg.write, pass in the writer. And I think we should be good. Okay, so we have an error up here. Oh, this is writer, not write. So let's go ahead and fix that. Save this. Let's go back to commands. Actually, I don't think we have any changes we need to make here, which is really nice. That just happened to work out exactly how we need it. So main Zig. Okay. I think our parser feels pretty good. Let's circle back to main Zig and take a look at process request. So we need to get that what's that called? Parser. Did I write that? Me 59 minutes ago. I guess I did write that. When did I write that? Resp.zig. Okay. So weird. So our request down here is going to be, oh, we're going to need to try this because it can fail, but we can do request.read, pass in our allocator. And again, at this point in time, that allocator that we're working with is an arena allocator. This code's not aware of that, but we know that because we wrote the code that calls this code. And then we're going to pass in our reader so that it can read from it. We can defer request.dinit. And then we check to see if it's a ping, and if it's a ping, we execute it. And then if request.is echo var echo equals commands.echo, something like this, dot value, not values, is equal to request.args index 0, and then return echo dot execute, and then we need to give that our writer. I feel like this is pretty good. We'll probably have a ton of debugging to do. The LSP has been behind me the entire time, so I'm not sure how valid most of this code is. But yeah, we can give it a shot. So I'm going to go to Ghosty, and give this a good old Zig build. There is no way. Okay, so I've got notes on my second monitor just to kind of help me make sure I'm staying on track. I'm just me going from the notes and writing as much code. There's no freaking way this builds. I am shocked. Okay, sure. Yeah. Ship it. Let's see. Let's give this to Codecrafters and let's see if it works. I feel pretty good about this. I did prototype some of this out earlier as well. So I feel pretty confident about what we are doing, but I don't feel confident that it is going to pass on the first try. Okay, let's give this a shot. Okay, yeah, that makes total sense. So okay, we have some issues. So response.zig 114, resp.zig. Oh, we're returning null, but we're not supporting a null return type on read length. And then that also means where we are calling it, this could be null. And we are probably not handling that as well. So we need to handle that too. So in the case of this, we can just say, we can use the or else keyword here. So if we have a null value, we want to do something. So I just want to return error.invalid character. Like that shouldn't happen. I guess another option we could do too is instead of returning null, we could just return an error that says, hey, this is an invalid character. That might be better instead of convoluting the type even further. Let's see, this is in the read method here. I guess there is a difference in our case between an error and a null value. So we'll keep it as is. And this, I think this really highlights it actually, because if we can't read anything, we can just return an empty string right here. Let's give this another go. Give it a big Zig build. Okay, cool. So we have some issues. No dinit in main Zig on 37. Oh, that is a function. I was not calling it. And then on line 14 of commands, we have an issue. Oh, yeah. we have eliminated this case, so we can't have that case anymore. So that works for me. Let's go ahead and give this another Zig build. It built. I'm kind of shocked, to be honest, that it built. Okay, cool. Yeah, I've got some notes on my second monitor that I've been referring to, but the fact that we were able to get through this with as few syntax issues as we ran into is a pleasant surprise. So no idea if this actually works though. So what we'll do is commit these. So we will commit, we'll just say hope, type in a passphrase, yeet this up to Codecrafters, and let this run, and we'll see how this goes. So welcome back. Your first build could take slightly longer. Please bear with us. While this is running, if you don't know what Codecrafters is and you somehow got to this playlist without knowing that, so Codecrafters is the tool that is guiding us through building our Redis instance. So this is it. It gives you challenges. You can come through and implement step by step. They have tests for you each step along the way. So it's a nice little test-driven development kind of experience, depending on how often you push. I have not pushed for this unit until now, so maybe not super TDD, more so just test to check my work, make sure that this works like we would expect. But they are running that stuff now. If you haven't signed up for Codecrafters, they have a free tier that has several, or at least one, to my knowledge, free course, I guess, would be an appropriate term for it, on at any point in time. So it is a paid product. You don't have to pay for it. That's exciting news. We'll come back to that in a second. It is a paid product, but you don't have to pay for it. But if you do want to try it out, I have a link that you can use to sign up. And it does two things. One, it links our account, so I can see the progress that you're making. So if you get stuck and you have questions, it's easy for me to find the progress that you've made. And then the second thing is that if you do decide to convert to a paying customer at any point in time, I get a small kickback, which helps me keep the channel going. So I always appreciate it. Yeah, okay, test pass. Cool. So, man, this was a long stage. So implement the echo command. You can see here, this runs Redis CLI echo raspberry, and it says receive raspberry back. So our test pass. So it's good to go. You can see that the ping command works like we would expect. It's handling concurrent clients with pings, responding to multiple pings with a single client, responding to a ping, binding to a port. So it's running tests from some of our previous stages, but we have this working at this point. So what they'll let you do now is they'll give you the opportunity to refactor code, and then you can, using the Codecrafters CLI or Git, you can push your changes to run the tests again, so you can refactor as much as you want. So I mentioned potentially looking at maybe taking an interface approach for these, so this could be a little cleaner. I still like that idea. This video has gone on for a very long time. I'm not going to do that in this video. If I find the time, I may try to do that before we do the next Codecrafters challenge, and I'll put that in as maybe a bonus episode for the playlist. But for now, I'm pretty happy with what we have. So I will go ahead and mark the stage as complete. So it looks like in the next one, we will implement the set and get commands. This will give us essentially the foundation of Redis. So the set and get are going to be the key things that we use in Redis for storing and retrieving values. Then we'll implement expiry. And then after that, we will have completed the foundation of this module. So the way that works is there are extra things you can add on. They're called extensions. So then after that, we will probably look at RDB persistence, file config, reading a key, string values, all that stuff. We can also look at replication. We can look at streams, transactions. There's a good chance that if we get to replication, streams, and transactions, I will implement those in Go first, so I can actually solve through the problems in a language I'm a little more comfortable with. But I have been really, really enjoying Zig, and I would hate to leave those on the table for Zig and not implement them. So we'll probably come back and do those in Zig too, if that's the case. Wow, what a long video. Hopefully this was helpful. If not, please let me know why it wasn't, because I spent way too much time recording this for it to not be helpful. My goal is for it to be helpful. So let me know in the comments below. If you haven't yet, here's a bunch of things. Subscribe to the channel, hit the bell to make sure that you're notified of new videos. Let me know how you feel about Zig and really this Codecrafters challenge in the comments below. And then finally, if you haven't yet, check out the rest of this playlist. If you somehow found this video, but you didn't see the first video where we knock out the introduction, the repository setup, binding to a port, responding to a ping, responding to multiple pings, handling concurrent clients, and more, you probably should check out that first video because you're probably a little lost on the second one. So yeah, check out the playlist. I'll put that here on the end screen and you can run with it from there. Hope you had a fantastic day and continue to do so. Have a good one.